Hello everybody and welcome to a little bit of a refresher on algebra and systems of equations. For a work sample you might get a question similar to the one that we have here. It'll ask you, one week Carlos bought 2 bags of Brutus Bites, 3 bags of Lucky Licks for $42.50. The next week he bought 5 bags of Brutus Bites, 6 bags of Lucky Licks for $94.25. And based on this information, we need to figure out the price of 1 bag of each type of dog food, the Brutus Bites and the Lucky Licks. So essentially when we're getting a question like this, we're going to have to think about a couple of things. The first thing is being able to turn this story context into a mathematical equation, and in fact a system of equations. And keep in mind, a system of equations means that we're going to have 2 or more equations. So looking at this information, we have to go from there. So we start by looking at how one week he bought these sets of bags for that price. So we've got 2 bags of Brutus Bites. So we're going to have 2 B's. And B I'm going to use to represent bags of Brutus Bites. And the word and is going to signify to us that we're going to be adding. So it's going to be and 3 bags of the Lucky Licks, which I will represent by capital L. And then it says for $42.50. That's going to be our equal sign. Equals $42.50. Right. So now we have 2 variables in one equation. That's not enough to solve. The fundamental theorem of algebra states that if we have 2 variables, we need at least 2 equations to be able to solve. But luckily, the next week, Carlos did another shopping trip. Here we've got 5 bags of Brutus Bites, 5 B's. 6 bags of Lucky Licks, 6 L's, 4, 94, 25. Now that we have our system of equations, now that we have 2 equations that represent this scenario, we have multiple ways where we can try to solve this. One of the ways we can try to solve this is through substitution. And the other is elimination. We could also graph, we could also make some very elaborate tables. Any of these things will work, but these are kind of the 2 fastest ways to do things. If we were to start with substitution, what we would have to do is we'd have to get one of these equations in terms of one of the variables. So for example, I could take this first equation, I could manipulate it, and let's say I wanted to get B by itself. So to do this, I have to get rid of my other variable term from both sides of the equation, giving me to B is negative 3 L's and 42.50. And then I would have to divide by 2. B is all of this on the right-hand side here, but because we have 2 terms being divided by a number, we have to divide the first term by 2 and the second term by 2. Boom. And so now we've isolated B. We can take what B equals, the box here, and we can go into our other equation and plug it into that B. We do a little bit of algebra from there to solve for L. We know how much a Lucky Lick is. We can then take that, plug it in, figure out how much our Brutus Bite is. From here, you should be able to do these steps. I just want to help you try to see how we can set these up to begin with. And this is substitution. For elimination, for a problem specifically like this one, elimination might be slightly less challenging. Because when we're doing elimination, we just want to make sure that our B's are above our B's, our L's are above our L's, our equals above our equal, and our constants above our constant. So the way that we have it written here, we have 2B plus 3L equals 42.50. 5B plus 6L equals 94.25. Okay. So now to eliminate, we want our variables to be the same. Our B is above our B, our L is above our L, our equals above our equal, and our constants above our constant. But we want to make it so that if we subtracted the second equation, we would get 0. Right now that wouldn't happen. 2 minus 5 would be negative 3, 3 minus 6 would be negative 3, and 42.5 minus 94.25 is some number that I'm hoping you have a calculator for. But what we can do is we can take this first equation and multiply it by 2. If we multiply all three terms, the b, the l, and the constant by 2, this will give us exactly what we want. 4b plus 6l equals 85 on the nose. Okay? I just doubled this, doubled this, doubled this. But now when I rewrite that second equation, 4b plus 6l equals 94.25, if I were to now subtract that second equation from the first, I would know that a negative b equals, what is that? 1075? Negative 1075? So I know that a bag of Brutus bites equals 1075. Now that I know how much a bag of Brutus bites is, I can plug it in, solve to see how much a Lucky Lick is, right? I just take this b, put it into any of these equations where there's a b, and that will give me my answer. I will now know how much a bag of Brutus bite costs and how much a bag of Lucky Licks costs. Now that's the two main ways that we're going to solve a system of equations. We might get another type of way of thinking about systems of equations. So I'm going to go to this other example here. So let's look at this one. A theater wants to take in at least $2,000 for the matinee. Matinee, of course, is an earlier showing of a movie or a stage production. So they want to bring in $2,000 on that matinee, and they're going to have a couple of things they want to think about. They have children's tickets that cost $5 each, and adults tickets that cost $10 each. And the theater can seat up to 350 people. This specific example wants us to find 5 combinations of children's and adults that will make that work. But we can just attack this by thinking about what would our system be like? What would our system be like first? So they want to make at least $2,000. Okay, so they want to make $2,000, and they're probably okay making more than $2,000, right? I've never met anyone who's when you give them $2,001 would be like, oh no, keep the one. So 2,000 is going to be less than or equal to the amount of money that they want to make. They're okay making more. Now, how are they making money? Well, they're making $5 off of every child. So we're going to call that 5C. And they're making, what is it, $10 off of every adult. That's going to be plus 10A. And then on problems like this, one of the things that seems to trip students up is what's our second equation, right? We know there's children, we know there's adults. What's our second equation? Well, it's given to us here. We know that the theater can sit 350 people. So we know we have 350 people. Can it seat more than that? Well, I mean, maybe technically, but probably the fire marshal wouldn't be cool with that. So we should gotta like sit 350 at maximum, but we're cool sitting less than that. So this is going to be greater than or equal to the number of people we're actually going to shove in there. Now, we can shove in any combination of children and adults, right? We could have 350 children in this theater, which sounds like one of my worst nightmares, but also it sounds like every day of work for me. Or we can shove in 350 adults, which would probably be way more profitable because adults have way more money. But what we do know is that it's some combination of children and adults. Some combination of children and adults are going to fill this theater. Once we have this, these are our two equations. Once we have these two equations, we can begin to figure out those combinations to make this work. But that's how we do it. We want to take these word problems, we want to convert them into mathematical language, and then we will use either substitution or elimination to find our solution. So best of luck on your work samples.